derivative. It'll just clean things up if you distribute that in before you get going. 3 cosine 1.25 pi times x minus, and then 4 times the 1.25 is going to end up being 0.5 pi. Okay, now we're ready for derivative. Okay, first term is just a plain old 5 by itself. Derivative of 5 goes to 0. Derivative here, I've got a multiplier of 3. Remember, multipliers carry along. Then I've just got a trig function with an ugly looking angle next to it. So, trig function is my outside, angle is my inside. So always start with the outside. Derivative of cosine is so we're multiplying, negative sign. Keep the angle the same. And I still have to multiply by the inside derivative. Inside, there's 2 terms there. So I'm going to put parentheses down. Okay, remember, pi is a number. There's only just the x here. So the derivative of x with the exponent of 1 comes down. It's 1.25 pi. That's my constant multiplier. It's going to carry along. Gets multiplied by the exponent of 1. So 1.25 pi. That goes away. And then this is a constant. A half pi. It's like 1 point something or other. Derivative of that goes to 0. It's gone. So if I wanted to simplify this a little, I'll bring this constant to the front, times by the 3 and times by the negative 1. So I'm going to go 3 times 1.25. That's going to be 3 so a negative 3.75. Pi is still there. Sine. And then my angle, 1.25 pi x minus 0.5 pi. Okay, so I've got my derivative equation, which is velocity. Maybe I'll put velocity. Is y prime. So now I can find the velocity at, I asked for 1.4. So that's just plugging, oops, I shouldn't have put that there. Velocity at 1.4. Putting 1.4 in for the x right here. And then cranking through it. And make sure you're in radian mode. Let's say mode. I'm in radian. Okay. I don't know what you need it to. There's nothing tricky there. Just everything in a row. And you should get 8.33. And it needs the units on it. And remember, we were doing the change in y over the change in x. So change in y is the change in feet over this was seconds. So it's feet per second. And then my second question, I'm going to squeeze it in here. Kind of ran out of room, even though I switched to a new paper. Is the mass moving up or down? Is the mass on its way up or on its way down? Be careful on this one. Okay, the derivative came out positive. So the velocity at 1.4 was positive, which means the distance is increasing. Oops. Velocity at 1.4 is positive, which means distance at 1.4 is increasing. Well, remember where the distance was measured from. It was from the ceiling. Well, if this is the ceiling and I'm increasing my distance from the ceiling, I'm going from 6 feet to 7 feet to 8 feet, the mass is actually moving down. So the mass is going down just because of what the distance was, the reference point. The reference point was above. If it was distance from the floor, then it would be moving up. But because it's distance from the ceiling, and that's increasing, it has to be going down to do that. Okay. Think you can do these? We'll practice one more together. These aren't quite that easy, I don't think. They're a little bit of a challenge. Okay, number 2. Okay, this time we have a water wheel. Rotates 6 revolutions per minute. And it's making 6 revolutions per minute. It has a radius equal to 7 feet. And it sits 1 foot into the water. Okay, write an equation for the distance from the surface of the water. Write an equation for the distance from the surface of the water. If after 2 seconds the wheel is at the top. Okay, so let me draw a picture of the water wheel. You've got the water wheel sitting on its axle. It has little buckets that catch the water all the way around. And it's sitting 1 foot into the water. So that's 1 foot below the water. It has a radius of 7 feet. And what we're doing is we're watching a single point on the wheel, and it says after 2 seconds of timing, that point is at the top. So then it gets closer to the water, below the water, gets farther away from the water, back at its max. So when the point is at the top, it's at its max. When it's farthest below the water, it's at its min, then it keeps doing that same thing again, making that nice cosine graph. So let's sketch the graph. Okay, so we need to know max and min here. So when the point is at the top, how high is it? It's from the surface of the water. Well, let's think about that. It's got a radius of 7. And if I go 7 straight down, the other 7 would be there. But I want to know how far is this point from the surface. So if 1 foot's below the water, there's 6 feet above. So this point would be a total of 13 feet above the water. So it's going to max out at 13 feet. The minimum is going to be -1 feet because it's below the surface of the water. When it's down here, distance from the surface is a -1, that direction. Alright, so at 2 seconds is when that point is at its max. So here's a 2 second, it's at the max. And then we'll figure out, so eventually it goes down, hits that -1, and starts going back up again. And then it'll go down, keep repeating itself. Okay, so we need to figure out how long it takes for it to complete 1 full cycle. Well, it's kind of hidden right here when it tells us that it makes 6 complete revolutions per minute. That means in 1 minute, that thing's going around 6 complete times. So I need to know, well, how long does it take to go around once? because that's one complete cycle. Well, think about a minute as being 60 seconds. How many seconds does it take to make one revolution if it's making 6 in 60 seconds? Well, if you go 60 divided by into 6 equal parts, it's taking 10 seconds. So that means this would finish at 12 seconds, or this is equal to a distance of 10 seconds up there. So that's going to help us figure out the B in a minute. So the equation then, you got to remember this. You're going to be having a quiz. You're going to have a partner quiz on this, and then it'll be you'll have to do it on your own on the big section quiz. So the general form is C plus A cosine B parenthesis x minus D. All right, let's go for the C first. Remember, C is your axis. Your axis is right in the middle. We need to know where that's at. Well, it's halfway between 13 and -1. So if you average 13 and -1, you'll figure out the C. So 13 plus the -1 divided by 2, it's going to be to a 6. So 6 should be halfway. That's giving me my 7 there and my 7 there, my radius. So the C is at 6. So that's going to be 6. Now amplitude, remember amplitude is the max to the axis or the axis to the min. Well, that's your 7. It's your radius. The B, remember, is not equal to the period. You have to do a little bit of math. 2 pi divided by B is equal to the period length of 10. Do a little cross product here. 10B equals 2 pi divided by 10. B is going to equal pi over 5. So B is pi over 5 times x minus the D is that shift over. How far over is that max? Instead of being on the axis, it's over at 2 seconds. So x minus 2. And there it is. If you can get the sketch and get the max and min and the complete cycle, how long it takes, these 4 values aren't too bad. All right, what kinds of questions do I have here? Okay, same thing as before. Let's go, how fast is that point moving at let's go 5 seconds. And is the point on its way down toward the water, or is it on its way back up? So, is it going up or down that point? Alright, so how fast? And we've got a distance equation, distance from the surface. So how fast is velocity? Velocity is the derivative of distance. So we have to do the derivative of the equation we came up with. So the derivative of 6 is first. Derivative of constant goes to 0. This is a whole term here. I see a multiplier and a trig function. Ooh, I forgot to, I like to distribute that in. So I'll have 6 plus 7. Cosine still have parentheses. Pi over 5x minus 2 pi over 5. Okay, so now I'm over here. So the 7's a multiplier. That just carries along. Same thing, I have a trig function left. Here's the outside. Here's the inside. Start with the outside. Derivative of cosine is always a negative sign. Keep the angle the same.